So we have next problem. So the signboard truss shown is designed to support a horizontal wind load of 4 kilonewtons. So the total force of this distributed load is equal to 4 kilonewtons. A separate analysis shows that what is that? 5/8 of this force is transmitted to the center connection at C. So 5/8 is transmitted to the center connection at point C, and the rest is equally divided between D and B. Okay, so let us try to determine P1, P2, and P sub 3. So we have 5/8 of the load is transmitted. So this is transmitted at C. So we now have your P to the 4 in here is equal to 5/8 multiply this one by 4 kilonewtons, and that is equal to 2.5 kilonewtons. Okay, so we have 5/8, so we have 3/8 of the remaining load, 3/8 of the remaining load of the remaining load. 3/8 of the remaining load is equally divided between D and B. So we now have 3/8 of the remaining load is equally divided between A and D. So 3/8 over 2 is 3/16. So for P1, that is now 3/16 of 4, and that one is equal to 0.75 kilonewton. And your P3 is also equal to 3/16 of 4, and that is still equal to 0.75 kilonewton. So we know now your P1 in here is, that is 0.75 kilonewton is P1, 2.5 kilonewton is equal to P2, and 0.75 kilonewton is equal to P3. So let us start at joint D. So this is now at joint D. So at joint D, so we have now your joint D. So this is now at joint D. So this one, and we have your P1 and your P1 in here is equal to 0.75 kilonewton. So that is. Now, let us try to assume that the direction of DE is in compression. So this is now your DE. And we now have your CD is in tension. So let us try to determine the slope of DE. So the slope of DE, so this is 2. That one in here is also equal to 2. So kalahati niyan is 1, and that is 1. Hence, that is 1. And therefore, the slope is 2 vertical to 1 horizontal. This is now the square root of 5. Let us try to get summation of forces. Horizontal is equal to 0. To the right, forces positive. So the horizontal component of DE is minus DE 1 over the square root of 5. And then plus 0.75 is equal to 0. Hence, the value of DE is equal to 0.75 by the square root of 5 is 1.667. That is 1.667 kilonewtons. We get a positive value again. The assumed direction is correct. Hence, your DE is in compression. Next, summation of forces vertical is equal to 0. We now have upward forces positive. Minus CD. Okay, plus the vertical component of DE, that is DE, multiply this one by 2 over the square root of 5, and that one is equal to 0. So minus CD plus DE is 1.667, multiply this one by 2 over the square root of 5, that is equal to 0. Hence, the value of CD is equal to 1.5 kilonewtons. That is again in tension. We get a positive value, therefore, the assumed direction is correct, and that is in tension. So we now have your DE, and we now have your CD. Let's proceed to joint C. So we have your joint C. Okay, so at joint C, we have your P2, and that is equal to, so this is now your P2, and that is equal to 2.5 kilonewtons. We now have your CD. Your CD is in tension and was found to be equal to 1.5 kilonewton. So we have your CE, and we now have your BC. Now your CE, and that is now your BC. So we have summation of forces horizontal is equal to 0, to the right forces positive. So, minus CE plus 2.5 is equal to 0. So, your CE is equal to 2.5 kilonewtons. We get a positive value, hence the assumed direction is correct. That is in compression. Summation of forces vertical is equal to 0. We have upward forces positive. So minus BC plus CD, which is equal to 1.5, is equal to 0. So your BC is equal to 1.5 kilonewton. We get a positive value. The assumed direction is correct, and that is in tension. Okay, so we know now CE, that is your BC, and we also have your BE. Let us now proceed to joint E. So at joint E, so we have joint E. So this is now your joint E. So we have your DE so at joint E, so DE, we have your EF, we have your CE, and we also have your BE. Now, your DE is, so this is now your DE. So the value of DE is equal to, at joint D, your DE is equal to 1.667. Okay, so this is in compression. So this is DE, which is equal to 1.667 kilonewton. Or this is equal to, we have 0.75, the square root of 5. And then we have your CE, which is in compression. So this is now your CE. And CE is equal to 2.5 kilonewtons. Now your BE, I will assume BE to be in tension. So this is your BE. And your member EF to be in compression. So this is now your EF. So let us try to get the slope of BE. So this is 1 and this is equal to 2. So again, we have 1 horizontal and 2 vertical. So again, that is the square root of 5. Similarly for EF. So your EF is also 1, 2, that is the square root of 5. Let us try to get summation of forces horizontal. Summation of forces horizontal is equal to 0 to the right forces positive. So we have your CE, which is going to the right. And the value of CE is 2.5. And then we have your DE is going to the right. So plus DE, and DE is 0.75, the square root of 5, or that is 1.667. And the horizontal component is multiply this one by. So the slope of DE, still the slope of DE is, this one is 1 horizontal, and that is 2, that is the square root of 5. So the horizontal component of DE is 1 over the square root of 5. And then we have also the so that is summation of forces horizontal. So we now have your EF. So your EF is going, so minus EF, multiply this one by 1 over the square root of 5. And then minus BE, 1 over the square root of 5 is now equal to 0. So we have 2.5 plus, plus 0.75 is 3.25. So this is 3.25 minus 1 over the square root of 5, so that is EF, minus 1 over the square root of 5, this is now your BE, and that one is equal to 0. Next, summation of forces vertical is equal to 0. We have upward forces positive. So vertical. So we have DE, so minus DE, and DE is 0.75, the square root of 5. Multiply this one by 2 over the square root of 5. Then plus EF, multiply this one by 2 over the square root of 5, minus the vertical component of BE, so that is BE, multiply this by 2 over the square root of 5, and this one is equal to 0. Hence, we now have minus 1.5 plus 2 over the square root of 5EF. And then minus 2, minus BE, minus 2 over the square root of 5, multiply that one by BE, is equal to 0. Call this the first equation, and this one is the second equation. Let us try to solve equation 1 and equation 2 simultaneously. Okay, so solve 1 and 2 simultaneously. So we have equation 1. Let's try to multiply this one by 2. So we have 6.5 minus 2 over the square root of 5 2 over the square root of 5EF, and then minus 2 over the square root of 5BE. That is equal to 0. We now have your equation 2, whereas equation 2 is negative 1.5 plus 0.5 plus 2 over the square root of 5EF. And then minus 2 over the square root of 5, that is BE, is equal to 0. So let us try to add the two equations. You try to add the two equations, then this is equal to, so we have 6.5 and then 1.5 is 5. So this is 5. So this will be 0. So minus 4 over the square root of 5. The square root of 5, this is BE, and that one is equal to 0. So let us try to solve now the value of BE. Solving for BE, this is equal to 5, the square root of 5 all over 4. It's 5, the square root of 5 all over 4. Hence, your BE is now equal to 2.795 kilonewtons. Again, we get a positive value. Hence, the assumed direction is correct. So what's direction of BE is in tension. So let us try. So we know now the value of BE. So let us try to determine EF. So from equation 1, so this is your equation 1. So we have 3.25 minus 1 over the square root of 5EF minus 1 over the square root of 5. BE is 2.79, and that is equal to 0. Hence, the value of EF is equal to, so your EF is now equal to, EF is equal to 4.77 kilonewtons. We get a positive value, the assumed direction is correct, and that is in compression. Okay, so we know now EF, and the other one, we also know your BC, EF, and BE. So that is BE, and that is now your EF. So let's now proceed at joint F. So let's proceed at joint F. Okay, so EF is 4.477 kilonewton, and that is in compression. So let us proceed at joint F. Sa joint F, proceed to joint F. Joint F, so we have your EF. So that is now EF. And then we have, so it's your joint F. So your EF is in compression. Ne. It's in compression. Makita met latan. EF is equal to 4.477. Makita nga ta. EF. And then, okay, so we now have your F. So this is your FG. That is your point A. So your FG, I'm going to assume FG to be in compression. So this is your FG. FG. And we now have your BF. So this is your BF. So we have the slope is 2, 1. So the slope is 2 and 1. So we have the square root of 5. So this is the square root of 5. Now, let us try to get summation of forces vertical. So summation of forces vertical is equal to 0. We have upward forces positive. So we have your FG, multiply this one by 2 over the square root of 5. Minus EF, and EF is 4.477. Multiply this one by 2 over the square root of 5 is equal to 0. Hence, your FG is equal to 4.477 kilonewtons. With a positive value, hence the assumed direction is correct, and that one is in compression. Next, summation of forces horizontal is equal to 0, to the right forces positive, minus BF. And then we have plus EF, which is 4.477. Multiply this by 1 over the square root of 5. Plus FG. And your FG is also equal to 4.477. So plus FG, which is equal to 4.477, 1 over the square root of 5 is equal to 0. Hence, the value of BF is equal to 4.004 kilonewtons. With a positive value, hence the assumed direction is correct, and that one is in tension. Now,